All right, two more examples with working with sex-linked traits. We're going to still stick with color blindness here. Color blindness is on the X chromosome only. It's a sex-linked trait, only on the X chromosome. And normal, the normal trait is dominant. The color blindness trait is recessive. So we're going to use a capital N for a normal gene and a lowercase n for color blindness because color blindness is a recessive trait. So when we use a sex-linked trait Punnett square, we know we have females and males. So we're going to start with a colorblind female. Now, females again are XX. Now, for her to be colorblind, she has to have both color blindness traits because color blindness is recessive. If she would have one normal trait, well, then that would show up because normal is dominant. So she's colorblind. The male has normal vision. So X, Y for a male. And again, guys, we only put that little trait, the N, on the X chromosome. The Y does not carry it. So he is normal gene. If we cross this first female, she has one normal gene and she has one recessive gene. So she sees normal, we call her a carrier. And then this female would have one normal gene and one recessive gene. Again, she sees normal, but she has the color blindness trait, so she sees fine, but she is a carrier, we call her. And then this male is colorblind, and this male is colorblind. So let's see what the question is going to ask you. It says, what are the chances of having a colorblind offspring? Well, of all the kiddos, so the girls would be fine, just carriers. The males would both have it. So 50% of the offspring would be colorblind. What are the odds of colorblindness for a female? Well, there's the females, 0% chance. So if these two people have babies, there's no way that they're going to have a female who's colorblind. But what's the probability of having a colorblind male? Well, if these two people have babies, they will always have, if they have a boy, he will always be colorblind, no matter what. And so that's the advantage that females will have, is that they have two X chromosomes. But males, if they have one bad recessive trait in their X chromosome, it's going to show up. Let's do one more example. So a female carrier, that means she has one healthy vision gene and then one color blindness gene, with a colorblind male. And again, males are XY, and again, this is only in the X chromosome. So colorblind is a recessive trait. So we cross. She would be normal, but a carrier. This female she has both recessive colorblindness traits, and that's the only way females can be colorblind, if they have both of the colorblindness traits. So she's colorblind. This male, again, normal. And this male right here would be colorblind. So what is the probability of having a colorblind offspring? So fine, colorblind, fine, colorblind. So 50% chance of having a colorblind kiddo. What are the odds of having a colorblind female? Out of the girls, there's two girls here. One would be okay, one would be colorblind. So 50% chance of having a colorblind female. The odds of having a colorblind male. Let's see. Normal, colorblind, 1 out of 2. 50% chance of having a colorblind male.